Yes. IC voltage regulators, already we have seen the positive and negative voltage regulators, fixed one. Today we will see adjustable voltage regulators. In the fixed voltage regulators, you have two types. One is the 7-8 series, another one is the 7-9 series. So 7-8 series is the positive voltage regulator, 7-9 series is the negative voltage regulator. Okay, so I hope we have stopped up to this in the last class. Today we are going to discuss in detail about the adjustable voltage regulator. So if you wish, please make the today's date and write the notes, else you take rest. Okay, let me finish my task. So adjustable voltage regulator, from the name itself, it implies that if you are giving unregulated input voltage to this particular system, based on the setting, it will give the output voltage. Say example, if I set my value as a 5 volt, irrespective of my input voltage, it will give 5 volt. In case if I change the setting to 12 volt, the same regulator will provide the output as a constant 12 volt, irrespective of my input voltage. Okay, that is the idea behind my adjustable voltage regulator. Okay, so adjustable voltage regulator, again it is 3-pin IC. It is named as LM317. Okay, it is a 3-terminal positive adjustable voltage regulator. This means this IC will provide you the regulator output voltage in positive values. Okay, so this is a circuit diagram. It's very much similar to the fixed voltage regulators. It is also a 3-terminal IC, but you have few more arrangements in your circuit. You have 2 resistors. Out of 2, one is the variable resistor. Okay, this variable resistor is going to play the vital role. Thereby, it is going to give some adjusted output voltage. Okay, so what are other things related to this? Here also we are having decoupling capacitors. Okay, then AC in the unregulated input we will give it to the input terminal. Then we will get the adjusted output voltage. So these are all pin configuration. The pin number 1 is the adjustable output. Pin number 2 is the output pin. Pin number 3 is the input pin. So pin number 1, if you adjust accordingly, you will get the output voltage in the pin number 2. Okay. So that's all regarding the IC. This is the one important formula. We are not going to focus on these derivations. Please make a note of this derivation alone. My output voltage depends on these parameters. One is the reference voltage. Another one is the value of R1 and R2. So the R1 value and R2 value. Then my I adjust value. So these are all some input parameters for this my equation. So the output voltage depends on these parameters. So that means if practically they are giving these values, that is IV reference, I adjust, and R1 and R2 value, you can predict what is your output voltage. Okay, so that is the idea behind this equation. Then so usually this regulator IC is used to regulate the voltage in the range of 1.2 volt to 37 volt. So this is the range of voltage what you can adjust with the help of this regulator IC. Okay, and also this regulator IC have one more limitation, that is your current. So the output current you can drive up to maximum of 1.5 ampere. Okay, please make note of these things related to your positive adjustable voltage regulator. The IC number is very, very important. That is LM317. The range of voltage is this. The maximum current what you can draw from this IC is this. Then this is the design parameter. Based on this, you can achieve the output voltage. Any doubt in this?
Answer.
Okay. So then second one is the negative adjustable voltage IC. Its name as LM337. Okay, LM337. You can find what is the pin configuration for the 337. It is little different from your 317. You can identify this output and input terminals are rearranged in 337. So here the second terminal is the output, but here the second terminal is the input terminal. Okay. Then here the third terminal is your output. Okay, so these are all few changes in your 337. Remaining things are very much similar. The connection diagram, everything is very much similar. Here the range of output voltage is minus 1.27 to minus 37 volt. Okay. Again, you have one design equation. So design equation is very much similar to your previous one. Here only one change is it is a negative output voltage. Okay. Then that's all regarding your negative adjustable voltage regulator. If you note down this, please tell me yes. Thereby I will change the slide. Yes.
Yes, sir.
Yes.
Sajid sir.
சொல்லுங்க சார்.
Okay. Yes. With this idea, I hope you can solve this question. Please try to solve. Calculate the output voltage of IC regulator circuit. For the IC voltage regulator, assume I adjust is equal to 100 milliampere. Then V reference is equal to 1.25 volt. Try to calculate the output voltage. Please calculate and tell me the output voltage, how much you are getting. It's a simple calculation. I hope you take down this previous equation. The equation substitute these values. This is the formula you require. V reference into 1 plus R2 divided by R1 plus I adjust into R2. Okay. Please substitute the values given in this equation and tell me your answer. What you will substitute here? V reference can substitute pannu
1.2.
1.25. Okay, into 1 plus what is the value of R2?
2
Kilo ohm. So 2 kilo ohm is nothing but 2000 divided by what is the value of R1?
220.
220 close bracket, then plus what is the value of I adjust 100 micro ampere 10 to the power minus 6 into what is the value of R2? 2000. So how to substitute in a calculator? Let me write it in the different color. How to substitute using your scientific calculator. First 1.25 into open double bracket 1 close bracket plus open another bracket 2000 divided by 220. It is like your C program. How many brackets you have opened? 2. So 2 in the 2 in the bracket in the close ஆயிடுச்சு in the bracket in the close ஆயிடுச்சு. So outer bracket I need to close one more bracket. Then again put plus, then open bracket 100. You will find the symbol in your calculator as a micro. Shift plus, which one will give you micro symbol? Can anyone tell me? Shift plus 4, am I correct? Shift plus 4 if you press, you will get this micro symbol. Then into 2000, close bracket. Tell me your answer, how much you are getting? 1.25 into, then 1 plus 2000 divided by 220, then plus 100 micro into 2000. How much you are getting? Any answer from your side?
12.81.
How much you are getting?
12.81, sir.
Very good, very good, very good. Thank you very much. That is your answer. Many of them don't have a calculator, I think so. If this kind of question asked in an examination, definitely you need a calculator. So try to buy one calculator. Already I have told which model you need to buy. Casio 991 MS. Okay, it is available in Amazon also. Casio 991 MS. So this is the calculator. It's a new model. Old model, the colors are different. Okay, so try to buy this one. The old model color clothing, if you click a image, see this is the old model. Okay, well, this is the old one, this is a new one. Functionality wise, both are same. Okay, yes. So sorry. So with this, the regulator portion is over. Also, module 1 is over. Okay. Can anyone tell me what is your module 2 portion? Module 2 என்ன இருக்குன்னு யாராவது சொல்ல முடியுமா?